Hello, everyone. Today, the topic of my presentation is smart grid and energy management system. This is the table of the content that I have covered in this slide from introduction to the end conclusion and then references at the last slide. First of all, there is an introduction of a smart grid system. Smart grid is basically an intelligent power grid. It facilitates efficient and reliable end-to-end intelligent two-way communication or power transfer system from source to the load. It also includes integration of renewable energy sources, smart transmission and distribution. As you can see from this picture that there are different renewable energy generation sources, there are different generation sources. They all are integrated and then the transmission and distribution is done smartly. Smart grid also helps to monitor the real-time data and control of power system as well as in demand response. It helps in demand response and demand side management. It also helps in power quality management. As you can see in this picture, there are different entities that are integrated and their information is sent to the control center using different communication technologies. These are the main components of a smart grid system. First one is the smart meter. Then we have phasor measurement, information transfer, and distributed generation. Smart meter is basically used for detailed information about electrical consumption. There are relays that send information to the central monitoring system. And smart meters also replace the traditional meters. And smart meters send the notification of a power outage and helps in power quality monitoring and management. And it also helps for the information sharing. Then we have phasor measurement. Phasor measurement basically helps to monitor the power quality. The phasor measurement measure the AC current waveforms. And then in wide area measurement system, they provide real-time data, phasor data concentrators, and then we have SCADA. And phasor measurement, basically this sends information to the central control station for better management of a power quality. Then we have a very important component of a smart grid system is the information transfer. Basically, there is a two-way communication in a smart grid system. There are different communication technologies that are being used by different microcontrollers like Zigbee, and it is also a low energy communication system and fast startup time. And there are different mesh topology connections that are used in information transfer. Then we have distributed generation. Distributed generation basically allow the connection of renewable generations, like we have solar, wind, fuel cell, and different kind of generation sources. It allows the connection. Generation close to the load basically improves the efficiency. That's why they have a distributed generation. And it also increases the reliability of an electrical power system in a smart grid. Then we have a general architecture of a smart grid that is basically divided into three parts. The first one is the generation part, where we have different kinds of generation sources like hydel, thermal, solar, and wind power. They all are integrated like a single entity. Then this energy is stored in the form of batteries or different means of energy storage technologies. Then this energy storage is basically sent via transmission lines to the distribution side. And at the distribution side, we have smart homes, smart buildings, and smart industrial area that basically use this power. Over here, there is a very important component that is IoT, Internet of Things in a smart grid. The dotted lines over here are basically showing the communication lines. The information about energy storage, about energy generation, about consumption, all of this information is sent to the main control center using IoT that basically analyze and forecast the data, and it analyzes power market about virtual power plants. So this communication model basically helps to analyze the power system, to analyze the demand to the generation in a much effective way than a normal or a conventional grid. Then we have energy management system. Energy management system is a very important part in a smart grid that basically increases the reliability. Energy management system is used to identify the systems performing the functions of forecasting, monitoring, measuring, and control of both energy generation and energy consumption. The current research trends are focused on developing a kind of energy management system that implements one or more of these functions like forecasting, monitoring, etc. And the design of EMS is quite a challenging process, especially for smart grids with increase, because we have like many integrated renewable energy sources and smart loads. So it's quite a challenging task. And we have a modern smart grid system. Modern smart grid system, basically, it is designed with the objective of delivering like distributed generation power, which is a characteristic of certain types of renewable energy technologies, such as solar energy or wind energy. Then in smart grid system, the design allows electricity to flow in two directions, including the exchange of information. Information can flow in two directions also. Then there are prosumers. In a modern smart grid system, electricity consumers play a role in electricity generation, allowing electricity consumer to manage their own consumption. And it also helps them as electrical energy to suit their lifestyle and their own behavior of using electricity efficiently. So a consumer has quite a good command in a modern smart grid system in order to manage their consumption or generation. Then we have the automation and the data communication. A large amount of data is exchanged between different devices. There is like a collaboration between processing, measuring devices, and it helps for the automation in a smart grid system. And modern smart grids are basically, they can even heal themselves in any hazardous condition up to some extent. Then we have the benefits of our smart grid system. Benefits mainly includes efficiency, reliability, and the environmental factors. In efficiency, it includes distributed generation, smart metering, and energy management system. In reliability, we have wide area monitoring systems. And in environmental factors, there is a renewable energy generation integrated with the smart grid. That is a very important impact of a smart grid system on a conventional power grid. And it also reduces the demand on centralized generation facilities. Although this is a very good technology, but still it has some like challenges that are still involved in this technology. The first challenge is the security and the privacy, because everything is smart enough and controlled by Internet of Things, artificial intelligence, and deep learning. Human interaction is not involved like conventional power system. So there is a risk of like meters can be hacked. These hackers can, they gain the control of even 1,000 or even millions of meters, they can increase or decrease the demand of the power. Any kind of hack, it really can disturb the system. It can disturb the reliability of a system. And as we have seen that, like in this picture, there are a large technological components are involved, different kind of software integrators. So it also like increase the concern of complexity rate of a system. Like it removes the clarity and accountability. And so in this way, this is quite a complex system and it has these kind of challenges. And then we have conclusion. Smart grid basically improves existing electrical infrastructure. It increases the reliability, efficiency, and it also helps to develop new kind of technologies that are involved in a smart system or in a smart grid, and further it leads to a smart city. And it also helps economically, and it plays a great and vital role in finances in markets. These are the references for my presentation from where I took help in order to make this presentation. Thank you so much for listening to my presentation. Thanks a lot.